So another little video here just to tell you something about something that just sort of appears once you've sort of built your quote, and it's this thing called Payback Calculator. Now this is really dangerous, by the way, so I just want to explain it to you first of all if I can. The Payback Calculator, this is what we would call schoolboy maths. It's very rough, and you can probably work that out. Because it doesn't include export, and obviously export is a benefit or a return, and so that would reduce the ROI, but it doesn't. And so that's something that we're going to need to work on using this schoolboy maths. But there's two important things to note here. The first off is that the payback calculator is roughly showing what the value of the PV system is over, in this case, 10 years. The lifetime cycle should be 20 years, so it should be longer. And the annual savings, 33,750 in this case, and the initial investment 115,584. So mathematically it kind of works, but it's still wrong. Oh, and also the return on investment, so the break-even point, 3.4 years. Mathematically it works, but it's kind of wrong. In fact, it's very wrong. So I'm going to do some work on this over time to rectify this, but this is really for use only in the illustration phase. It's very rough, and it's to use these schoolboy maths to say, when you invest this much in a PV system of this size, the financial payback, if you like, which will include the savings in electricity, plus any export income that you're going to get, plus any kind of savings when you have a battery included. Batteries are a separate point, of course they are. That will be your annual savings, or your annual return, if you like. The initial investment is whatever it is, and basically initial investment divided by the annual return, that equates the length of time it's going to take for you to achieve break even. So in this calculation, as I say, it's mathematically correct based on the input figures I put up here. Now remembering I put these figures up here, wherever they are, the energy analysis. Okay, they were guesses a lot of the time. But if they were accurate from a PV sol, these would kind of reflect what's in the PV sol, but they would still be wrong for a quote. And the reason for that is they're schoolboy maths. Okay, they're basic maths. They don't deal with what a concept in accounts known as net present value. They don't deal with any depreciation. They don't deal with any interest. They don't deal with any inflation in the energy prices, which, again, we don't know what they are. They don't deal with general inflation. So they can't do this because that's too complicated a series of calculations. So here's my advice to you. We're going to still use this area, okay, to create a payback calculator that will be included within the illustration. And we'll build this and develop this using these schoolboy maths that we've been looking at. But for the purposes of your final quote, it's not going to be good enough. And it will always be different to what the PV sol calculates, because the PV sol calculates using this accountancy standard called VDI 6025, okay, and that is different to the schoolboy maths that we will use, that CPQ can possibly use. So remembering the payback calculations, they are rough as you like. They can only be used really in the illustration document, and the PV sol will show the proper payback financial analysis, which is more comprehensive, that hopefully your clients will want to see. We will find a way of summarizing and signposting those within the quote document, but for now, explanation to your client is fine. These are rough figures. What you should look at is what's in the PV sol, because those have been properly calculated using sound accountancy methodology, and hopefully that will push the buttons that your clients want to hear. Okay, so that's payback calculator. Okay.